Okay, good morning, afternoon, or evening, everybody. Welcome to the Explore the Entire Earth Every Day with Satellite Imagery from NASA Worldview webinar. And this is your host, Jennifer Brennan. So most of you have already noticed this, but while you're logging in, you'll see the two optional polls at the bottom of the page, and we really appreciate your feedback on these polls. They help us to continually improve upon this webinar series. I've got 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. And I would like to start by going over just a few housekeeping items or logistics related to this webinar. First, to ensure the best audio experience, the conference has been placed in silent mode. So if you have any issues or if you have any questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. And this works like a chat. We are recording this webinar, and we will post it both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a few days of completion. And I do plan to provide that information to all of you at the end, by the way. The presentation files will be available for download at the end of the webinar. You'll have a web links pod where you'll be able to click and go directly to the Google Docs for their presentation. As far as timing is concerned, this webinar is 1 hour long. 45 minutes are allocated to the presentation and live demonstration with an additional 15 minutes for the question and answer period. After our speakers have finished their presentations, what we'll do then is we'll move to a final set of polling questions, and then from there we'll transition directly to the Q&A period. So you will have an opportunity to ask your questions throughout, with the exception of during the live demo. And again, you'll use the Q&A pod for this. Questions will not be answered using the raising hand function. It has been disabled. And then just one final note, depending on the volume of questions that we receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. So as you can see here, during today's webinar, we will have 2 speakers. Our first speaker, Ryan Bowler, is the NASA Worldview Project Lead here at Goddard Space Flight Center. And our second speaker is Taylor Gano, who is the lead developer for the NASA Worldview Project. What we are going to do at this point is we're going to move to the agenda. All right. Hopefully everybody can see that. Our first speaker will start off by providing an overview of the NASA Worldview application, and he will highlight some of the key features and functionality. He will also showcase a couple of Worldview use case examples. And from there we'll transition to a live demonstration, and finally we will end with a snapshot of future capabilities. With that, it is my pleasure to introduce today's speaker, Ryan Bowler. Ryan?
Thanks, Jennifer. Welcome, this is Ryan. I'm here with Taylor Gano.
Thank you.
Okay, great. All right, let's get started before anything else breaks. So, okay, overview of this talk. We'll be talking about NASA's Earth observations, about Worldview's web interface and looking at those observations, and then hopefully how that can lead to interactive data discovery. So starting us off with what our observatories do and what they see. So we started doing this at NASA quite a while ago. So in 1960, we launched TIROS-1. And this is an artist's conception of it, majestically soaring above the Earth, looking at this hurricane that they drew. And the actual result of what they saw in 1960, well, I mean, it was okay. It was our first attempt, and black and white TV. It kind of makes sense for that era. And this is our first try at satellite observations. Moving on later in the decade, we started the Nimbus 1 series of spacecraft, and we started to get a little bit better at things. So we have some more calibration, some more detailed information. We can start to do some basic science with it. And one of my favorite pictures here is this is a nice history lesson here for me, to learn how they actually operated the spacecraft in these days. And they had, some pretty mechanical-looking gizmos and gadgets here on this machine, and pretty cool to see that how much things have changed since then. So speaking of, here's our current orbiting fleet of spacecraft. We have 16 operational missions. A lot of them are NASA run, and some of them are partnerships with other agencies as well, like USGS and NOAA. So we'll show some observations from these spacecraft here today, and right now actually. So this is from the Aqua satellite, which launched in 2002. But this picture is from this year in the Indian Ocean. This is the strongest hurricane ever recorded in the Indian Ocean, with winds at about 280 kilometers per hour, 170 miles per hour. And so you can start to get a sense for the clarity that we can see with the imagery here. And you can zoom in even more and get more detail, but this is sort of zoomed out to give you a sense of the extent of this particular hurricane. We can do other things like look through vertical slices from orbit down to the Earth. So, again, we have this surface picture on top here of a similar instrument, or the same instrument actually, but then we have this red line that goes across, and that's where another spacecraft, Calypso, flew over. And what it can do is it uses basically laser detectors to determine where there's clouds and dust and smoke. And so we can determine, in this case, this is a wildfire over Borneo, mostly for agricultural reasons, and some of them are uncontrolled, actually, in this case. And you can get a sense for how high the smoke is and how thick it is. And this can be useful for measuring or predicting things like how far that dust is going to travel. If it goes higher, that could mean it goes farther. If it stays low, then it can stay more local. At least that's my understanding of it. We can do things like quantifiable scientific products as well. And so this is sea ice concentration at the North Pole, which we'll talk about in some decent detail a little bit later. But this is an example of looking at the entire Earth, including at the poles, to see things like sea ice concentration. And so this changes on a daily, monthly, annual basis, and we can measure this quantitatively and over time. This is from the GCOM-W spacecraft, the Answer 2 instrument, which is a collaboration with the Japanese Space Agency, JAXA. And one more example here, a couple examples. I'll start with the flashy animating thing on the right here, which is sea surface temperature over the course of about a month last fall. And it loops here, but you can see how we can measure the temperature of basically the entire Atlantic Ocean in this case, and how that changes over time. And so in this case, it's getting cooler as winter in the northern hemisphere starts to settle in. On the left, we're looking at some fires from the VIIRS instrument on the SWOMI MPP satellite, which is a collaboration between NASA and NOAA. And on the top, you see a natural color image of what the fires look like, along with these red dots, which represent hot spots or thermal anomalies or things where the satellite thinks that there's an actively burning fire. On the bottom, you see the same red dots, but then the underlying base layer there changed to be a false color image. So this is using images or wavelengths that are some outside of the human visible range that are converted to be visible to the human eye. So we're looking at now green is healthy vegetation, and then you can see these sort of reddish brown marks to be where the fire has burned, so burn scars basically. Excuse me. So that's kind of some examples of how the imagery can be used, but let's talk about how do you actually get to that point where you can look at that kind of data. So we'll start with the good, which we described a little bit here, where we have it's really a rich and diverse data set. And I personally get really excited about this because you just feel the potential for everything you can do with the data set. With all of the data sets, there's so many to choose from. They support a lot of different applications. We've got a long history of things from 1960 to the present. We cover the globe with a lot of these products. And like I said, it covers a whole lot of scientific domains. Another good thing is, disk space has really gotten a lot cheaper and a lot bigger. So in the past, things had to be stored on tape or other sort of offline methods. These days, we can put up a couple of computer racks and everything. Well, it's more than a couple racks for all of Earth Science Holdings, but you get the sense of being able to store everything online and accessible pretty much instantaneously. So that's the good stuff. The challenge is, though, across all those products, there's different data formats. So those of you who have used NASA's Earth science data before, they can be stored in different kinds of ways, like HDF or NetCDF or GeoTIFFs. They can be processed to different levels, and you sort of become familiar with those over time as you start to learn more about the products. They're stored as different spatial resolutions. They cover different areas. They're stored in different map projections. So there's a lot of, it's difficult. If you learn one product, you may not know how to use a different one. And with hundreds and thousands of products, that makes it challenging to get up to speed with learning everything that we have. Another thing is a lot of our data sets are time varying, so they're not all supported. Well, time varying data sets aren't necessarily supported very well across different existing tools that are out there. They often expect just one specific time step, whereas ours, as you've seen, cover the course of many years. And some more challenges, we've got a lot of this stuff. So, by virtue of being around for a while, and some of the data is very large, even on an individual data set level. So we ingest a lot of data, about 16 terabytes a day. We have about 15 petabytes online. And there's a whole lot of products, and some of the file sizes are big. So what we're really trying to get at here is to enable exploration, analysis, decision support by people that aren't experts and people on the outside who didn't necessarily spend, years getting a PhD, or experts that have to spend months getting to learn how to do things. We really want to reduce that barrier to learning and using our data. So this talk is going to be about taking a visual-first approach to finding and using our data. So probably most people have heard the phrase, a picture is worth 1,000 words, and that's certainly true in this case. But I want to add one extension to that, which is because sometimes all you need is a picture. And so in a lot of cases, maybe you just want to know where that fire is burning or where this iceberg is, and a picture will be able to tell you that without needing to learn these data formats and so forth. But it's certainly not a cure-all. There's certainly many ways where you still need to use the data to do analysis and many other things. But at least as a first step to learn what data is available, and also in some cases, that could be your last step as well, if that's all you need to know is where certain things are, or some qualitative things. So taking this visual first approach, we've built a couple of things here. So first off, there's the Global Imagery Browse services, and they provide open access to full resolution imagery derived from NASA products. It's basically, if you're familiar with web services, they allow you to build your own clients and connect to them and basically customize it to your needs. So we built a general purpose client called Worldview, which uses those web services, uses Gibbs. And Worldview is an open source web browser based client that lets you interactively explore that imagery and then download the data if you want to get the data as well. So to do some marketing here, our marketing bullet for Worldview itself, which we'll be talking about here in more detail, it's designed to encourage you to discover natural phenomena through a map interface. You can find near real-time and historical imagery in its underlying data. You can learn more about the individual imagery layers through some pretty detailed descriptions of each of them. You can also look at the poles in polar-specific map projections. So that being said, we can start to give a demo of these things. So jump out of presentation mode and go to Worldview. So when you go to Worldview, you will get prompted to take a tour here. I will skip that tour since I'll give it to you all in person. So when you get into Worldview, you have this map-based interface here, and you start to see some colorful pictures of the Earth. In fact, look in the corner, this is today's date. So this tells you where we are here. I can click and drag the map like you would Google Maps and drag around. You can zoom in here with the plus and minus, zoom out and so forth. Something that's different that you don't see in something like Google Maps, though, is this ability to change the time. So what I can do is I can go back in time. I can click this left arrow, and I'll go back one day at a time here, or I can drag this this time widget and see how things change in time. So if I go back to today again here, we can see that the area here west of eastern U.S. is black. And that's basically due to the fact that the satellite hasn't gotten there yet, or we haven't gotten the data from there. But this is basically as new as the satellite imager gets, which is really a couple of hours old in most cases. So the satellites orbit, most of our satellites orbit from pole to pole. So to illustrate that, I'll actually jump through something very quickly before I explain what I'm doing here. I'll turn on the orbit tracks here. So this is one of our satellites we're looking at. This is imagery from the Terra spacecraft, the MODIS instrument. What I just added is the orbit tracks for that Terra spacecraft. So you can see that it takes this polar orbit here, where on the day side of the Earth it goes from north to south. You have the timestamps as well of when exactly it crossed different points in time. So you can also notice we get a lot of questions about these gaps here in between these swaths, and basically the field of view of this spacecraft isn't quite wide enough to overlap each other at the equator. If I change the dates, the areas where those gaps are change from day to day. So you do get full coverage basically every other day from any single spacecraft. But we can do other things as well, and I'll turn off those orbit tracks. We can turn on other spacecraft as well to fill in that coverage and get different perspectives. So I can use this layer selector on the left to turn on another spacecraft. This is the Aqua spacecraft with a similar instrument called MODIS on it. And I can toggle between these two. So these are basically two views of today of the Earth from two different spacecraft at slightly different times of day. There's one more as well, which was more recently launched, which doesn't have those gaps in between the swaths. This is the SWOMI NPP satellite and the VIIRS instrument. So we get a sort of unbroken image of the Earth this way. So what I'm doing here is I'm turning on and off these layers on the left. They're divided by base layers and overlays. The overlays, basically, you can keep on stacking on top of one another. You can turn on some things like labels. And you can also rearrange the order of these as well. And I'll actually demonstrate that in a little bit. But the short answer is you can click and drag, and you can change the order of which one is on top. It doesn't really matter too much right now because these overlays are all pretty sparse. So let me go through a specific example of how somebody could use Worldview to look at wildfires. So recently there's been two very large fires in California. Actually, you start to zoom in. So this is yesterday, and you can start to see quite a bit of smoke up here in Northern California. If I go back a day or two, there are other fires here in Southern California. So you can start to see with this visible product, this is the corrected reflectance product in true color. So this is what your eye would see basically if you were flying in space. So you can start to see some things like wildfires burning in Southern California. I can go back a couple of days, and you can see that there's fairly serious amounts of smoke being given off by that fire. But if we want to get a more detailed picture of these fires, we can add more layers which are tailored to look at those fires. So I can click the Add Layers button, and basically I'm given a set of layers to choose from. They're broken up either by hazards and disasters or scientific disciplines. So in this case, I will choose hazards and disasters and fires. So there are things like fire and thermal anomalies, there's aerosol optical depth, and so forth. And we'll load a couple of these here for this demo, but I'll start with the fires product. And this one I'll start from Terra, Modus, and then I'll load one from, say, Swomi MPP. You can see some good details about, if you're just learning what these layers are, within this layer selector, you can look at these descriptions. And so they'll tell you things like the basic background about what they're good at doing, things like looking at fire detections and thermal anomalies in this case. It'll tell you the resolution of that data. It'll tell you about the spacecraft that it's coming from and the time range that it's available. So if I close this window, I go back, you can see all these red dots now, which represent where the spacecraft detected actively burning fires. So again, you can change the time here, and if I go back to July 22nd, you can see it was pretty small, and probably if I go earlier, there was no fire at all. Like as I step through time, see it starts small here, and I can zoom in a little bit if you're having a hard time seeing that. Zoom in, and then very quickly on July 23rd, it expanded, and then eventually gets to be a little bit better and hopefully entirely out here by yesterday. So that gives you a sense of what's going on the ground. Actually, there are some other products too that could be interesting to examine this fire more. So I'll go back to my add layers, and I'll look at different wavelengths of light, which can help us see through the smoke a little bit and analyze the ground cover. So I'm going to turn off these fire layers now, like the points, and then this is now looking at basically the same area in the infrared and some visible channels as well. So the burning areas, the actively burning is in the bright orange, and then the areas that have already been burned are in the brown. And as we go through time, those brown areas will remain for quite a while because it's going to take some time for that vegetation to grow. So if you want to study exactly how much area that wildfire burned, this sort of product can really help you tell. So even though in this particular case there's no more fires burning, you can see that there's quite a wide area burned. So one last thing with this example here, we've looked at the ground, but we can also look at what's going on in the air. So these fires put off a lot of smoke. So if I go back here and I want to look at the air quality basically in that area, I can add an aerosol optical depth layer. I happen to know that the AURA satellite and the OMI instrument, you can look at things like aerosol index or aerosol optical depth, and there's some pretty these all may sound similar up front, but there are different purposes for each of these products. And so our hope is that with these descriptions, you'll be able to tell which product works the best for you. So right away, we'll see this giant blob here of what's detected to be basically smoke and particulate matter hanging in the air. And so that color scale is here. So you can see that the red is the most intense and the green is the least intense smoke, and nothing is nothing detected. So, okay, and one last part of this demo is if you want to get to the underlying data now and do some analysis, you can use the download tool here. So there's a tab here for downloading data, and what it lets you do is pick individual granules. And so these granules are basically the way that data gets divided on our servers. And so each of these plus signs represents a different data granule. So I can click plus there, I can click plus here, I can go back or forward a day and try to get some more data, which is relevant. And basically just picking the data of interest rather than downloading everything up front and then finding what you need later. So after that, you can click download selected data, and it gives you basically a list of those data products which you just requested. So that's going to be it for this part of the demo. Let me jump back to the presentation now. Jump into presentation mode. and give you a quick overview of how Worldview has been used by some other folks. So in general, we get about 3,000 unique visitors per day to using Gibbs, our imagery services. About 3/4 of those visits are for Worldview-related requests. And the media uses that imagery quite a bit. So here's the dust storm that was happening in the Middle East. They started off by showing what life is like on the ground, but then they also included imagery of what it looks like from space. And so you start to get a sense of how widespread this particular event was and give you context for that event. The Weather Channel here used some of our imagery for things like flooding. Here's a case where we had some flooding in 2013. Before and after, I'm sorry, flooding was in 2015. The normal time when there wasn't flooding was in 2013, and it's flipping back and forth between those two. This is using a false color combination again, and so the deep blue represents areas of water. And you can see that in 2013 there were areas of brown, which is where there's usually dry land, but in 2015 those areas of dry land became water. Worldview's also been used to do to make scientific publications. So in this case, scientists are studying the aerosols above Southeast Asia. It's also used a fair amount in social media as well. So here's an example of somebody looking at a typhoon off the coast of China and Japan, and showing also the population density in those areas. Here's a volcanic eruption from South America, and then the ash plume from that. And here's sort of a longer-term look at a drying sea. So at this point, I'm going to turn it over to Taylor Gano to give an advanced feature walkthrough of Worldview. So Taylor, take it away.
All right. Thanks, Ryan. Thanks, Jennifer, and hello, everyone else. I'm going to start where Ryan left off, and we're going to explore some more data. Hopefully, you'll find interesting. First, let me get rid of the layers that are in this list. I'll start out with sort of a blank. All right, so first I want to point out the toolbar in the top right corner of Worldview, which you may or may not have noticed. There's several options here, and the one that I'm going to demonstrate to you first is this projection icon here. So basically, we're looking at a geographic projection of the imagery right now. And if you click here, you'll see that we have other projections available. We have Arctic and Antarctic, the polar views. And so for this demonstration, I'm going to use the Arctic view to look at Earth from above, or from the north. And this is an interesting area to look at if you're studying sea ice concentration and sea ice in general, as Brian mentioned earlier. We're going to look for this area in Alaska called Nome. Oh, I've lost myself. There we go. Okay, so of course we need to go back a few months, so let's go back to about April, and maybe about the 5th of April. Start there. So this is the season. This month of April is when the sea ice starts to really begin to break up and melt away for the summer months. And so if I were interested in shipping to northern Alaska, to Nome in particular, this would be interesting data for me to see, because I need to know how to navigate through these sea ice concentrations. And the visual imagery here can help do that. So you'll see particularly over the course of this month that the sea ice really starts to carve a path to get to Nome. So if we're scrubbing the timeline here over the month of April, you'll see that there's a big gap starting to open up to northern Alaska. And we might want to say that this is a really good image and I want to share this with somebody else, or instead of using just like the screen capturing tool of your operating system, we have this image download tool that directly queries the server from where we get our data, the Gibbs servers. You can resize the area that you're used to, or sorry, that you would like to, or that you're interested in. Let's say that looks like a pretty good image. In this dialog box here that opened up after pressing the image icon, you can select the resolution, 250 meter to 10 kilometer per pixel. There's several different image formats here. There's JPEG, PNG, your typical image formats, and then there's GeoTIFF if you want to export it and import the data into a GIS application. There's also, we have KMZ, which is, I'm going to switch back to the geographic view for a second to show you KMZ. We have a KMZ option here, and that can be used to export to Google Earth, for example, and overlay your data onto Google Earth. Going back to the Arctic view, sorry for that small disturbance. So yeah, let's say this is about a 5 megabyte file and a 250 meter. I'm going to query the server for this image and these layers that are loaded in here. I'll click download. I'll get another tab here, and there's our finished image. So this is an actual query to the Gibbs servers, our backend for generating this imagery. And this is the result of it. You'll see that it's actually bigger than the box you'll see here because we selected a larger resolution. So that is the best way to get your imagery out of Worldview. And from there, let's zoom out a little more and see the entire Arctic region. I'm going to add a couple more layers that you may be interested in seeing. Again, for sea ice, I'm going to add Anser E sea ice concentration, which is a historical product. So in order to view that, you'll see that nothing's changed here, even though it's in the sidebar. That's because this is a historical product that the data has ended in about, as you can see here, about September 2011. Scroll over back in time, and you'll see that it goes from about 2002 to 2011. And I know that it's this product because if I highlight over the layer list item here, it highlights the item in the timeline. Is there's a white outline on the timeline there of that object that we're looking at. So that's what we're seeing from. That's when we have available data for this particular product. So if I go back in time here, you can see the data that we were looking for, and let's scrub over the year so you'll see the change in the sea ice. So during the winter, it's at its peak, and then about September is the minimum of the concentration of sea ice. So that cycles. And you'll see that we're using this rainbow kind of color palette, but if you're interested in, if you're used to seeing this data in other color palettes, then we have that available option to you. So I want to point out that on each one of these layers, there's a button here for opening a dialog that where you can adjust particular options. Like for the place labels, there's not going to be much here except for adjusting the opacity. But that's all done on client side, and there's a larger one here for layers that have actual data like this one does. And in this dialog box, as I said, I might be interested in seeing this data in the format that I'm used to, which might be in this blue shade here. If I click that, then the color palette is now updated to this new one. Then I can, of course, change the opacity on this one. I can do thresholding if I'm only interested in data values above certain percentages on this one. So 0% being no sea ice coverage, and then 100% being full sea ice coverage. Let's say I'm interested in 16 to 100%. So that just cuts off the bar and shows you only those values. But if I want to see the entire bar squashed into this threshold, I can also do that by checking this box, and you get a little more detail into the data values that you see on the map. And again, this is all done on the client side, so if you were to try to export this or query the server for this image using this tool, you'll get a little dialog box here that says you have to change it back to the default one that is provided by the server. So that's what happens when you click there. It will change it back to the default. So that's basically it. So we have, as you notice, we have several different views on the timeline here. Like this is our default one usually, which is over days, and we have this months one when I just demonstrated. If we move to September, which is the sea ice minimum of the year, we can move back to years. Or sorry, we can zoom out to years in the timeline, and now we have each one of these tick marks is represented as the entire year. But if we click on one of these, the date stays in the September region, so we're able to browse the sea ice minimum per year on the fly just by dragging the time slider here. So that you'll be able to get a good representation of sea ice concentration over a 10-year period and the changes in it. So, okay, that's it for that part of the demo. Now I just want to bring up the point that Ryan mentioned earlier, that Worldview is open source, so all of our code is on GitHub under github.com/nasha.gibbs, and there you'll be able to find all of our code that we use to deploy Worldview. Here's the main repository. It's called Worldview, and we have instructions on deploying it and an easy way to get it up and started. If you are familiar with Vagrant, that's a really easy way to get an instance of Worldview on your machine. We also have this other repository here that is for configuration options. This is where we have our particular layers loaded into Worldview that we're interested in, and the branding for Worldview. And if you wanted to clone both of those repositories and build Worldview to whatever you need it for, then you're able to do that. You can switch out the branding. You can add different layers, and so that's all on GitHub. And also, as Ryan mentioned, again, we are running. We're using Gibbs as our imagery provider, the global imagery browsing services, and so we have this example repository here, which provides a lot of different ways to implement Gibbs imagery over several mapping clients. And there's live links here for easy browsing. Here's the basic open layers one, which is just like the corrected reflectance layer. You just get the imagery basically over that one day. There's a example of a rolling 7-day slider, the timeline, but in a smaller format over 7 days here. So if you really want to get familiar with using Gibbs imagery in your own clients, this is a good place to start. There's a leaflet client, which is another mapping library. We actually use open layers, but that one's great too. There's a cesium client, which is a 3D client in the mapping libraries world, and this one uses a little bit more CPU when it's idle, so it's a little more heavy for displaying imagery, but still. All right, so that's all of the, I think, all the examples I really want to go through. The rest are there if you want to check them out. And that's it for the development side of Worldview. And for the rest of the presentation, I'm going to turn it back over to Ryan, and he'll help you with the demonstrations of what we're going to get into next. Thank you.
All right, thanks, Taylor. Let's jump back to the slides here and talk about how some other people have used Gibbs actually. So on the outside, as in not within NASA, these are things that aren't, this is not any official endorsements by us, but these are people that have used the imagery services, used Gibbs for their own purposes. And so there's an app in this case called Rip Charts, which is basically meant for anglers to try to find fish. And they use things like the sea surface temperature and chlorophyll of the oceans to help guide that community. Completely different side of things. There's a site that lets you basically browse the Earth and look for artistic pictures and print your own posters of the Earth. And they'll print the picture out for you and send it to you. But it uses the imagery that Worldview uses from Gibbs to make those posters. And another completely different one from the previous two, PBS made an educational tool meant to investigate severe storms and encourages users to sort of interact with the imagery and learn more about it. So let's see, so where are we going next with Worldview specifically? So we have very soon on the way, let's see, let me open a new tab here. This ability to look at natural events that are happening right now on the Earth. So you'll soon see this Events tab here. And what it'll let you do is click on individual events, like here's a tropical storm happening this week. And you can follow it as it progresses over time. Jump to, say, some other tropical storms here. And things like wildfires. And the idea is to basically give you a sense of what's going on the Earth right now. Because if you start with Worldview and you're given this kind of blank slate, it may be difficult to sort of get a sense of what's going on if you're not looking specifically for something. And so this is hopefully a way to guide users into seeing what's going on right now. If you'd like further information about any particular event, you can click on these links, and basically it'll give you details about that particular event from the source. So that's one of our upcoming features, which we're really excited about. And that uses a database from the Earth Observatory Natural Event Tracker. And so this is an open set of web services that anybody can build clients on as well, called EONet. Another feature is this ability to do animation and playback. So you can set a start time and an end time. This is sort of a rough example here of what's going on, but you get the sense, and we're really excited to release this one too. You set the start time, you set the end time, you can set the speed, and then watch something change over time. And then also be able to export that animation to animated GIF or animated GIF, depending on your pronunciation of these things. Let's see. I think this is the last thing I'll demo here. So this is a running data values feature, which lets you basically move the mouse, or as you move the mouse over the surface, as you move it over the map, you'll get what that data value is underneath. So this is a giant exaggeration here of what that mouse cursor would look like. And as you move it, you'll see this little marker here move based on basically the data that's underneath it. So it's saying, I'm blowing it up here for clarity. It's basically saying that underneath the cursor, the water temperature is 28.7 degrees Celsius, and a good time to go swimming off the coast of North Carolina. Okay, sorry, one last thing, which is this ability to look at things like data curtains. So, in one of the initial examples I showed, it had this vertical profile of smoke and dust and clouds. This is from the Calypso satellite, this sort of vertical profile. I'll show a quick demo here of what that looks like, where you can move the Earth and then basically pop up these LiDAR-based profiles of the Earth. And so ideally what that helps you do is correlate what you see on the surface here, or at least from above. You can match these clouds to sort of a height and a density vertically here. Besides that, we're adding a whole boatload of new products, which I'm really excited about. So not just new products, but also going back in time. So I should caveat some of this with saying, even though our project as a whole, the organization I'm in, serves over 7,000 different types of products, Worldview and Gibbs has on the order of about 200 of those products, and we're working to add a lot more of them right now. And so this is a sort of a brief list of some of the things we're working on right this second. And then there's two more that I just want to highlight here. One of them is this Beers Day-Night Band, which basically shows nighttime imagery. So this is looking at Texas and looking at city lights here. But you can also start to see things like gas flares from drilling along southern Texas there. As one example, you can see many other cool things like ship traffic because of the lights on the boats, and aurora, and other fun things. And then one more, this sort of a longer-term data product called Weld. It uses Landsat, and it'll be cloud-free mosaics from 1985 to 2010, with some gaps in there. And there'll be monthly and annual composites. So you'll be able to see changes in land usage over time. So we're also excited about those two in addition to the many others that I mentioned before. So hopefully here's some takeaways for you. Hopefully this webinar has helped you to learn how to use Worldview to discover some interesting data. If you're developer inclined and you're interested in building your own apps or using scripts to use NASA imagery, then hopefully this gives you some examples of how that can be done. And we hope you'll stay tuned for more products and features. And to that end, actually, we have a brand new beta tester mailing list for Worldview. So if you're interested in learning about upcoming previews or upcoming features and would like to provide feedback to them, we'd love to hear back from you. So we won't spam you. We won't sell your email address. We'll just let you know whenever we have cool things to show. And there's a link to sign up there. And that link is again on this page here too, along with our contact information and ways to get to the app itself and to the code. So with that, I will wrap up here and I'll turn it back over to Jennifer. So thanks everybody for your attention and look forward to seeing your questions.
All right. Thanks, Ryan. Thanks, everybody. What we'll do now is we will move to the final set of polling questions. I'll give these questions just a couple of minutes or so, and from there we'll move directly to the Q&A portion of the webinar. And thanks again for your patience in the beginning. When I post the output file, I'll be able to remove the 5 minutes or so you won't have to. If you're interested in listening to the presentation again, you won't have that interruption at the beginning. All right, well, thanks. We'll give these just a couple minutes, and then we'll move directly to the Q&A. Okay, everybody, we're going to give this just another 30 seconds or so, and then we'll move directly to the Q&A period. All right, everybody, with that, we will move to the Q&A period here. And if you have a question, go ahead and type that on the right-hand side. And I'll give it a minute here to see what kinds of questions we may have, and then we will answer those questions. While we're waiting for that, in the bottom lower right-hand side of the screen, all of these, the Worldview presentation, it's actually a link to the Google link for that particular file, and then there's a link to the Worldview application, and then I've also provided a link to our NASA Earthdata website as well here. And that will be a persistent feature, so if you're listening to this webinar later on our, by accessing it via the Adobe Connect catalog, you'll be able to click on those links and obtain access as well. Are there any questions? There's got to be a question. Anybody? Okay, on the left-hand side here, we have information about our social media accounts. We've got a Facebook account and YouTube, which is where the webinar will be posted. Currently, we have about 65 additional data discovery and data access webinars that are there. All right, great. We've got our questions. All right, so the first question is, Ryan or Taylor, is there a way to see names of specific granule IDs you are looking at?
Chris Desher, I see. Well, you see them after you add them to your cart, basically. So when you hover over them, I think you see a timestamp right now, but you don't know what the specific granules are until you actually add them to your cart and then try to download them. But if you would find that useful to know whenever you are hovering over them, let us know, and then we can try to put that in.
Okay, thank you, Ryan. The next question is, are you considering adding Landsat?
So Landsat, is a USGS product, which we love our USGS partners. And we, how can I put it? Well, there's a NASA-based Landsat product, which I mentioned there close to the end, called Global Weld, which uses Landsat data to make these global composites. And so we will have that in Worldview and Gibbs for browsing. In terms of future Landsat, we'd love to see it. It basically isn't in our hands to do it right now. It'd be more up to the USGS to serve that, and we'd love to add it if it were available as such.
Okay, thanks, Ryan. The next question is, does the application work best in particular browsers? It crashed when I first opened it in Chrome. Oh, no, that's really disappointing to hear. We use Chrome and Firefox here and some of Safari. If we haven't seen it crash in Chrome that often, but if it did for you, then please send us an email, and we can try to look at your specifics to try to recreate it on this side and try to solve the problem. But sorry to hear that. We do test it though in at least those three browsers and a little bit of IE and Edge. And mobile too, as well. Actually, yeah, we forgot to mention that, but Worldview is usable on tablet and phone devices as well. Okay, thank you, Ryan. So the next question is, the download looks a little complicated. Any advice? Oof. Well, it is complicated, unfortunately, in some senses. Well, for some data products, they're not easily available. So I kind of showed you a semi-pleasant one where you can click individual granules spatially. Some of them, though, only have timestamps on them, so that you're just given a list of timestamps. In that case, you want to add an orbit track layer to understand when
the particular granule was observed, and then match that with the timestamp of the granule in the list that you were just given. It's really on a case-by-case basis, and we're trying our best to make that as easy as possible, but that's the best I can tell you right now. If you continue to have problems, again, get in touch with us. We can try to make that clearer.
Okay, thank you, Ryan. So the next question is a comment and a question. I noticed the fires and thermal anomalies layer is exclusive to Worldview. Are there plans to expand this to Gibbs itself for developers?
Ooh, so it technically is open, although you're right that it's not listed in the public list of layers, because those layers are served somewhat differently than the other layers, since those are point-based products. So we are working to do better support for vector products, including things like fires. And you're still encouraged to use those fire points. It's just not very well documented right now. That's a good point. We should still list that publicly, even though we haven't. So I will make a note to do that. And it's just accessed in a different way than the rest of the layers. So thanks, Edmund, for that point.
And I should tell everybody that the Q&A log will be provided to our speakers, and so feel free to email me if you'd like to get in touch with either one of them offline. I mean, the information, their contact information, you'll find if you click on the presentation file link, which is the first one in the pod at the lower right-hand corner. But certainly you can also email me, and I can put you in contact with one another if any of your inquiries require some further discussion offline. All right, so the next question is, for the image snapshot, what are the license specifications? Just proper acknowledgement similar to other NASA data?
Yep, that's right. So all of our data is free and open. So we would like if you say that it's NASA Worldview, where you got the image from. Some people do and some people don't. We would ask that you do, though, for proper crediting. And so our government sponsors as well know that people are using it. That's really a big help to us in that respect.
And Ryan, in that vein, do you have a citation policy on the Worldview site anywhere?
I believe so. In the About section, I think there's, if you go up to the upper right corner, there's an I button, and then there's an About section, and then there's a section on image citations there. So that's a good point. Thank you, Jennifer.
All right. You're welcome. Sure. The next question is, what are the hazy swaths that appear in the middle of the image swaths?
So that, I should have mentioned that. That's a good question. That is the reflection of the sun over the ocean, actually. So the way the satellites, a lot of them do the observations, is the Earth sort of rotates underneath the satellite, and usually the satellite is pretty much directly between the sun and the Earth. And so you're seeing basically the reflection of the ocean, reflection of the sun off of the ocean.
All right, great. Thank you, Ryan. The next question is, could you provide an extra parameter to the Gibbs Rest interface that would provide for the latest true tile when the time parameter is omitted?
Actually, I think we do that right now. Well, except instead of adding an extra parameter, I think if you leave time off, you get today's date. I'm not totally sure about that. I'm, say, 70% sure on that, but I could be wrong. But that may work. So otherwise, that's a good suggestion, because I assume you could create some pretty simple clients that just request the same thing every day, and it just gets today's imagery. So thanks for the suggestion. If it doesn't do it automatically, then we'll look into that to see what happens.
Okay, and there's a little bit of follow-up to this the last question, and that is that the tile can be black, though, is what the is what the person who asked the question said.
Okay, yeah. So actually, I see a follow-up to that underneath that, which says, yes, we default to today whenever no data is provided.
Right.
But that's true. So it's possible, though, that that tile may be empty or black whenever you request it, and that's only because the satellite image hasn't gotten there. The satellite hasn't observed the data, and we haven't processed it yet. So it's tricky. It's tricky to make it so it only shows up if there is an image there, because that could be a mix then of today and yesterday, depending on what time of day you make that request.
Okay, thanks, Ryan. And then the next question is, I'm a user of the USGS Earth Explorer web portal. Is there any way to link from there to Earthdata? That's a question. You know, we did have some folks from our land processes DAC participating today as well. I'm trying to look and see if there's anyone still there. I would have to check that out, Antonio, and I can, you know, email you. I'm not certain that there's a direct link from Earth Explorer back to Earthdata, but I think if you're accessing it through the NASA Land Processes DAC, that there's a really easy connection. So I'll check that out and I will email you. Are there any further questions? Well, I would like to thank everybody for joining us today, and thanks especially, you know, we ran a little bit over due to a technical glitch in the beginning. Thanks for your patience. For all of our repeat participants, it is great to see you again. And our next webinar actually will be held on August 24th, and that will feature the GPM and the TRIM precipitation products at our NASA Goddard Earth Science Data and Information Services Center here at Goddard Space Flight Center if you're interested. So you can sign up to our webinar announcement email listserv if you go to tinyurl.com Earthdata webinar. That is where we will have our all of the previous year's webinars are posted there. There are direct links, and then there's also information about how to sign up to receive announcements for upcoming events. And again, it will be posted to YouTube in a couple of days, and I'll send everybody the links for that recording if you'd like to go back through and check out some of the steps that our presenters went through today. So thanks very much, everybody. And if there are no further questions, what we'll do is we'll log off from the audio on the telecon, and I'll leave the virtual space open for an additional 10 minutes or so. If you have any questions or concerns or comments, feel free to enter those into the Q&A pod. And again, we appreciate your time today, and I hope to see you again in the future. Thank you to Ryan, and thank you to Taylor for your presentations today.
Thank you, Jennifer, and thank you, everybody.
Thanks.
At this point, we will log off from the telecon, and I'll leave the virtual space open for another 10 minutes or so. Oh, you're very welcome. Thank you, Antonio.